Prepare to be dazzled by Zeiss's revolutionary journey in optical technology, where precision meets innovation. But how did this optical powerhouse navigate through challenges to become a global leader? Keep watching to uncover the fascinating tale behind Zeiss's rise to prominence. In the competitive semiconductor sector, the production of high-precision lithography machine lenses holds significant importance. Zeiss, with its robust technical know-how and continual innovation, has emerged as a frontrunner in the global lithography lens domain. Evolving from manual polishing techniques to today's automated manufacturing processes, Zeiss has encountered and overcome numerous obstacles along its developmental trajectory. Initially crafting lenses through manual polishing, Zeiss has ascended to a prominent position, serving as the primary supplier of lenses for worldwide lithography machines. Now, let's delve into the topics at hand. 1. How did Zeiss transition from manual to automated production methods, and what impact did this shift have on its standing in the lithography lens market? 2. What role did technological advancements play in Zeiss's journey, and how did these innovations influence the broader semiconductor industry? 3. Confronting intensified market rivalry and evolving technological requisites, what strategic plans does Zeiss have for future development? How do they plan to address challenges stemming from the global lithography machine market? In the semiconductor industry arena, Zeiss lithography lenses are highly regarded worldwide for their exceptional precision and reliability. The semiconductor industry chain is bifurcated into upstream materials and equipment manufacturing, as well as downstream integrated solutions markets. Crucial equipment like lithography machines and etchers are predominantly overseen by Europe, the United States, Japan, and South Korea. While China's SMIC possesses partial autonomy in etching machines, the realm of high-precision lithography machines remains under the control of the Netherlands' ASML. Additionally, Germany's Zeiss, standing as a top-tier supplier, not only holds a leading position in the optical field, but also serves as the exclusive provider of lenses for EUV lithography machines. Zeiss, a globally recognized name in the optical domain, was established by K.L. Friedrich Zeiss, a proficient technician. Beyond possessing profound technical acumen, Zeiss harbored an unwavering passion for crafting precision optical equipment. In 1846, this visionary founder laid the foundation for Zeiss in Germany, marking the commencement of its illustrious journey. Initially, Zeiss concentrated its primary production efforts on manufacturing microscopes, swiftly garnering acclaim within the scientific community for its impeccable craftsmanship and stringent quality standards. However, Carl Zeiss's ambitions extended beyond the conventional. To broaden the company's horizons and augment the technological sophistication of its products, he enlisted the expertise of Ernst Abbe, a gifted physicist, to serve as the company's technical researcher. Abbe's arrival undeniably infused Zeiss with fresh energy. His scientific curiosity and inventive mindset propelled the company towards significant breakthroughs in optics research, gradually positioning it as an industry frontrunner. With the backing of Carl Zeiss, Abbe took a pivotal step by establishing the Carl Zeiss Foundation, redirecting the company's focus towards long-term technological advancement over short-term gains. By relinquishing all his shares to the foundation, Abbe redirected a portion of the company's profits towards technological innovation. This move not only solidified Zeiss's leading technological stance, but also laid a robust groundwork for future advancements. Simultaneously, Abbe prioritized employee well-being and growth, allocating a portion of profits towards employee benefits to ensure their financial stability and foster a culture of excellence. Through such profit-sharing initiatives, Zeiss nurtured a distinctive corporate ethos, attracting top-tier scientists and technical experts while fostering employee loyalty and a sense of ownership within the company. This culture remains ingrained within Zeiss, serving as a driving force for its ongoing innovation and progress. Under Abbe's stewardship, Zeiss implemented a pioneering 8-hour work system, a rarity at the time, positioning the company at the forefront of technological development and manufacturing for the ensuing century. During World War I and II, Zeiss attracted the attention of the United States, marking significant chapters in its history. During World War II, Zeiss supplied various optical instruments, including telescopes, cameras, and sights, to the German Army. As the war neared its end, U.S. military leaders swiftly seized control of Zeiss, which was under the ownership of the former Soviet Union, with plans to transport it to West Germany using hundreds of trucks. The U.S. intervention, armed and strategic, resulted in the extraction of key technical personnel. These individuals were relocated to West Germany, where they established a new entity known as Zeiss Company. Meanwhile, the former Soviet Union retained the technical personnel and product equipment, establishing the old Zeiss Company within a short time frame. In the aftermath, the two Zeiss entities charted separate paths, facing disparate destinies. The West German Zeiss, benefiting from the Western free market economy and a culture of technological innovation, ventured into the global market, unveiling a series of groundbreaking optical products and earning global acclaim as an optical powerhouse. In contrast, the East German Zeiss, constrained by socialist policies and limitations, maintained a modest level of research and development, but struggled to expand its market presence and international influence. Throughout the Cold War, the rivalry between these two companies mirrored ideological tensions. However, as time passed and East-West relations thawed, alongside Germany's reunification in the 1990s, the two Zeiss entities began exploring the possibility of reunification. Following intricate negotiations and reorganization efforts, Zeiss eventually merged, gradually bridging the gaps in their technological history and brand identity. In the new century, Zeiss expanded its optical technology exploration, broadening its product range from consumer-grade camera lenses to advanced medical and industrial equipment. Venturing into the semiconductor industry, Zeiss collaborated with ASML, leveraging over 3,400 IPC units to drive microelectronics advancements. Initially prioritizing microscope and medical lenses, Zeiss treated lithography machine lenses as secondary due to limited demand. Merging with Zeiss Enterprise in 1990, the company's workforce swelled to 80,000, yet faced financial instability amidst Japanese competition. Despite the organization's size, only around 100 focused on lithography lenses, lacking significant updates. As the global semiconductor industry grew, manufacturers like ASML raised the bar for Zeiss lenses, demanding higher quality. Zeiss relied on experienced technicians and hand polishing to deliver top-notch lithography machine lens modules, despite limitations of manual polishing requiring complete remakes for minor flaws. While refining photographic lenses, Zeiss tackled challenges in lithography lenses. With the semiconductor industry booming due to smartphone popularity, ASML, collaborating with TSMC, challenged Japanese dominance in lithography machines. Zeiss shifted focus to producing lens components for ASML's high-precision machines. Today, Zeiss stands as a global leader in precision optics and technology, influencing development worldwide. Despite enduring challenges, Zeiss remains dedicated to its vision, shaping its own legacy. Today's video encapsulates Zeiss's journey, emphasizing its unwavering pursuit of precision and technological innovation. Automation and CAD systems have propelled Zeiss to increase production capacity while ensuring product consistency and precision. These advancements have solidified Zeiss's dominance in the high-precision lithography machine lens market, making it the preferred supplier for many semiconductor manufacturers. Zeiss's innovation has also introduced cutting-edge technologies like EUV lithography, revolutionizing semiconductor manufacturing with smaller and more complex circuit patterns. Facing intense market competition, Zeiss remains committed to investing in research and development to enhance lens performance and production efficiency. Exploring new materials and manufacturing techniques ensures Zeiss's leadership in the ever-evolving industry. Zeiss's progress not only cements its position in the market but also drives the technological revolution in semiconductors. For those interested in understanding industry trends, Zeiss's story offers valuable insights into maintaining leadership amidst global competition and shaping the future of technology. Looking ahead, we anticipate Zeiss's ongoing impact in the lithography machine market and its influence on semiconductor industry development. With technology advancing continuously, Zeiss lithography machine lenses are poised to maintain a pivotal role in the semiconductor sector, driving advancements toward greater precision and wider application domains. What's your take on Zeiss's impact on the future of optical technology? Feel free to share your thoughts and perspectives in the comments section below. Don't forget to become a part of the Revel Discovery community by hitting that subscribe button to stay informed about the latest technological advancements and innovations. Explore endless tech possibilities for an exciting future.